Okay, so it's 10:30. So I can see that we have 38 attendees already. So welcome everyone to this breakout session focused on DNA-based digital data storage. So I have the pleasure today to introduce you to my colleague Roumen Borissov, who is in charge of these very interesting challenges. Roumen has a PhD in theoretical and mathematical physics. So previously he worked as assistant professor in physics at Sofia University before joining the European Commission. Roumen now is the acting program manager at the European Innovation Council and SMEs Executive Agency, and is in charge of this challenge that is going to introduce you with some slides. So, Roumen, if you want to already share your presentation. And so we are going to listen to his presentation, and at the end you will have the opportunity to ask questions using Slido. We will try to address all of them, but if not, of course, they will be answered in written via a Q&A file that will be published on our website. Roumen, the floor is yours.
Thank you. Thanks a lot. I hope you all can see my presentation.
Yes, we do.
Okay. And I mean, during the presentation, if you have problems, you can communicate with Isabella. She is going to help me with this. Thank you very much for the introduction. As Isabella said, my name is Roumen Borissov, and I was appointed to be the acting program manager for this topic. I'll present to you without much deviation what we have in the work program and in the challenge guide, trying to explain all the details. And at the end, you'll have the opportunity to, throughout the presentation, you can ask questions via Slido, and at the end, we'll go through the questions and I'll try to answer your questions. If I cannot, we will contact you later on with all the answers to the questions you have asked. In order to ask the question, just a reminder, you have to go to Slido at slido.com and use the password or whatever it's called, EIC Pathfinder, and choose the correct breakout session in order to ask questions about the session on DNA-based digital data storage.
Yeah, it is possible also for the speaker to type directly the question on the right pane of your screen normally. So they can also use Slido in this right pane of the screen.
Okay. All right. So as I mentioned, I'm going to go in detail through the call text in the work program, which is the most important document you have to follow, to study, to understand in order to prepare properly your application, and also through the challenge guide, which provides some additional information on the background, but also details on how we are going to, at the very end of the evaluation, use specific considerations in order to build a consistent portfolio of projects. So this is the outline of the presentation. And in the very beginning, we have the overall goal of this challenge. This EIC Pathfinder Challenge is to explore scalable and reliable high throughput approaches for using DNA as a general data storage medium. So it's a very high level goal, and it basically tells you from the very beginning what is it we're looking for, and now we'll drill down into the details. Just to mention why why is it important that you have to really understand and follow all these details? It's because they're part of the evaluation process of the applications you're going to submit one way or another. For example, when we evaluate the excellence of your proposal, we definitely are going to, the external independent experts are going to look into how well your proposal is addressing the overall goal and the specific challenges defined here in the work program. And also we will check from the very beginning if the scope, if the proposal submitted is really in the scope of the challenge. And then we'll discuss also the expected outcomes and impacts, and they're also part of the evaluation criteria, in this case of the impact criterion. So this is the overall goal of the challenge, and then here is the scope of the challenge. So the proposal should address this scope. Solutions would need to address the read, write, and edit operations of digital data in synthetic DNA, capturing the expected advantages of high density and stability, longevity of this form of data storage. Then the use of DNA sequences as chassis for non-standard forms of information coding or of other polymeric substrates and related coding decoding techniques are also in scope, provided they entail at least similar benefits as the state-of-the-art DNA approaches. So other polymeric substrates also can be used. The proposed techniques should deliver qualitative advances in key parameters such as throughput, DNA length, reliability, and coupling efficiency, speed, and cost. So there should be definitely qualitative advances in these parameters. And finally, on the scope, beyond the usual storage applications, there is also scope for radically different scenarios for such a technology. For instance, for data processing, in vivo sensing, or fingerprinting. This expands a little bit the scope beyond the standard storage applications. So when you prepare your proposal, the first thing to look at is if it addresses the scope of the challenge. Moving forward, the challenge has 3 specific objectives, and we expect the objectives you put in your proposal to be in line of the objectives of the challenge itself. So the objectives we're looking for new approaches for coding, decoding, modification, or computational use of digital data in synthetic DNA or other sequence controllable polymers with quantitative targets, theoretical and technological. The second objective, proof of concept of technical feasibility with indications of at least state-of-the-art benefits and major operational characteristics. So going beyond the state-of-the-art is good. For example, extreme densities, longevity, stability, and also going well beyond for some of them. For example, for speed, cost, or accuracy. And the third specific objective we have for this challenge is end-to-end scenarios of use, be it for data storage, for archival, but also shorter-term storage, or for other purposes like sensing, cryptography, or computation that exploit the benefits of this technology. So again, the objectives you have in your proposals should address these objectives, should be in line with them. The other main components of what we're looking for are defined through the expected outcomes and the expected impact. The expected impact usually is a long-term impact on the surrounding of the topic of the stakeholders and the activities related to this topic. The expected outcomes are more kind of short to mid-term impacts, if you like. So the expected outcomes are a range of new technologies with clear benefits and steps towards widening scope of applicability of DNA-based data storage. So we are hoping through this challenge to come up with such new technologies. Midterm means like of the order of 5 years or so, for widening the scope of the DNA-based storage. And also among the expected outcomes, a broader range of scenarios and uses for DNA-based data technologies. And then the more long-term impacts, we're looking for emergence and anchoring of European innovation ecosystem on DNA-based data technologies and applications, including through involvement of relevant partners and end users, and the contribution to standardization in the field and benchmarks to gauge progress in this field. So, as I mentioned, the expected outcomes and impacts are going to be addressed by the evaluators when they evaluate the second criterion, which is actually impact. In addition to all these details, the overall goals, specific objectives, expected outcomes and impacts, there are some eligibility conditions for the applicants. In this particular case, for this challenge, it has been decided that the proposals can be submitted also by single applicants or by consortia, depending on the activities to be performed. And just to emphasize, because some of you may be familiar with the standard approach to application when we are expecting consortia of 3 partners from 2 different member states. Here in this particular case, for this particular challenge, when we say consortium, we mean that in case of a consortium, your proposal must be submitted by the coordinator on behalf of the consortium. That includes at least 2 independent legal entities. We're not looking for 3, 2 is sufficient. The legal entities may, for example, be universities, research organizations, SMEs, startups, natural persons. In the case of single beneficiary projects, mid-caps and larger companies will not be permitted. So that's the only restriction we have here. We don't fund large companies when they're the single applicant with the proposal. So as you can see, these are very, I would say, relaxed conditions, depending on exactly what is it you're planning to do, how you're planning to address the objectives and the expected outcomes and impacts. You can either submit as a single legal entity, or you can build a consortium of representatives from universities, research organizations, and so on, in order to be able to really take care, address all the objectives of your proposal. Okay, all this is kind of a legal text, which is part of the work program. This is the must. This is something you really have to address, and your proposal is going to be evaluated on the basis of how well you address all these expectations for objectives and impacts and outcomes. On the other hand, the challenge guide, which was published when the call was open about a month ago, contains additional information, mostly background on the challenge, why we decided this is a important challenge, and why we believe that advancing the developments in this field is going to be important, and that's why we'd like to have good applications to fund. So a few words on the background. Since I mean this is a very general considerations, as the world becomes increasingly digitized, the number of data sources is rising dramatically. And in addition to the standard online activities, the Internet of Things, smart cities, personal devices, autonomous vehicles, environmental sensors, and so on and so forth all contribute to a rapid rise in the volume of data being generated. And a significant proportion of this data, which is generated, is not yet stored beyond the short term. But some long-term projections forecast that overall demand for digital storage will exceed supply by up to 3 orders of magnitude within the next 20 years. So definitely there is a big question about data storage, especially long-term data storage, and we expect that the DNA-based data storage may be a possible solution to this problem. As you may know, the main challenges, which, I mean, I'm sorry for the overuse of the word challenge, but here the main problems which have to be tackled are related to scalability, sustainability, integrity, and reliability. By scalability, what is it? Data scalability factors do not simply refer to storage capacity. They also refer to the number of different data sets to be handled or related to one another, the frequency with which data sets are updated and or queried, the complexity of updates and of queries, and the physical location, distribution, and replication of the stored data sets. All this is related to the scalability. Then we have the sustainability. It's crucial to reduce the energetic requirements imposed by data storage. The existing storage methods require the mining of large amounts of metals, gold, copper, aluminum, as well as rare earth materials that are difficult to process and which generate significant toxic pollution. So the sustainability is something which we haven't paid much attention until now, but it is becoming really important and crucial to take care of. And then we have integrability and reliability. Existing media can offer data retention periods that last on the order of decades, but this comes at a cost of, in terms of proper environmental control, periodic data integrity checks, and other physical overheads. So this reliability and integrity should be also addressed when working on this particular topic. So just to mention what are the interesting features of the DNA as an alternative storage medium. For example, the storage density. The raw information density of DNA has been calculated as more than 1 exabyte per cubic millimeter. And although traditional storage devices are moving beyond planar layouts to 3D structures, the inherent volumetric storage of DNA may also confer significant potential benefits. In the challenge guide, by the way, there are references on works on DNA storage. You can study, look at. Here's a picture from one of these references, which is cited on the slide, showing the information density for different storage devices, starting with the CD and all the way to DNA storage. So clearly, there is a lot of potential in DNA. However, all the challenges have to be taken care of. Another interesting feature of the DNA as an alternative storage medium is its robustness. DNA is remarkably stable, especially when stored in carefully controlled conditions, uh, maintaining pH, temperature, humidity, and so on. Another interesting feature is related to the universality of the DNA, in particular the genetic code, the mapping between nucleotide sequences and amino acids that make up proteins. This genetic code is shared by all living organisms, meaning that it's one of the best studied and developed encoding schemes in existence. And another feature is the resource requirements. Once data is properly encoded in DNA, it requires very little resources for its long-term storage, which is also extremely important. It can be maintained with little energy for a long time. It's also interesting to look at the possibilities for dynamic DNA storage. Although much recent attention has focused on the use of DNA as a long-term storage medium, we should not overlook its potential as a dynamic medium for writing and reading in a dynamic way in short periods of time. And also, we should keep an eye on living cells as possible storage media. Until now, when talking about DNA, usually what is meant is a synthetic DNA, but also it's possible to use living cells. The natural environment of DNA is the living cell, and evolution has produced a diverse toolbox of biological processes for copying, proofreading, and even propagating DNA sequences. So there is a lot, on the one hand, to learn from nature. On the other hand, we can really check if we can use living cells as such storage media. And then we come to the discussion of the portfolio. Now, let me explain briefly the main difference between the calls for the challenges which we have now and how the applications, the proposals are evaluated, and what we had in the past, for example, in Fed Proactive. Although it seems quite similar, again, we have a top-down call. We define all these details which I explained to you, the objectives, and so on and so forth. And we have the standard evaluation procedure where independent experts are going to look at your proposals and will use the criteria for evaluation defined in the work program to assess the proposals and to provide comments and scores. So at the end of this first step of the evaluation, we will produce a list of proposals. Your proposals to the challenge are going to be ranked according to their scores. And then comes the second step in the evaluation, which is based on the so-called requirements for building a consistent portfolio of projects. Just to give you a rationale for this, I mean, typically when we select projects for funding, they work on their own separately, and at the end, we receive results from the different projects, and they don't benefit much from the fact that actually that's a set of projects working on more or less the same topic with the similar objectives, and clearly all they address the objectives already explained in the work program. So the idea is to build a portfolio from the top ranked proposals after the evaluation based on the criteria for evaluating, and see how we can build a portfolio where the quality of the portfolio is bigger than the sum of the benefits from the individual project. So put it otherwise, to encourage the projects to work together, to interact, to learn from one another, to share their experience, maybe the difficulties they have overcome, maybe work on exploring different directions, and just benefiting from the fact that there is exploration of many new directions within the scope of the challenge. So the idea is to, at the final stage, select from the top proposals those which kind of optimize the value of the portfolio. So the goal of building such a portfolio is to achieve a diverse set of projects in terms of, in this case, for this challenge, in terms of time frames present, underlying substrate, and potential applications. So we're looking for diversity, again, in terms of time frames, underlying substrate, and potential applications, while encouraging proposals that demonstrate end-to-end integration and interoperability where applicable. So on the basis of this overall goal, we have prepared, in this case, two different categories, and all think about the categories as specific dimensions. All the proposals received are going to be mapped against these categories. The first category is the so-called storage duration. The committee, the evaluation committee, at the end of the evaluation process, will seek to facilitate a set of projects that operate across the spectrum of time, from long-term archival, cold storage, to medium-term working storage, and short-term dynamic storage. So we would like to have diversity among the projects selected in terms of time frame. The other category which is going to be considered is the substrate. Whilst acknowledging that the bulk of the portfolio may be comprised of projects that operate on synthetic DNA in vitro, the committee will encourage the investigation of alternative substrates, such as non-natural polymers or living cells. Again, in this second category, we'll be looking into a diversity of the substrates. And actually, it's natural, if you look at the categories, to decide what the specific considerations are going to be when building the portfolio. Here they are laid down in specific terms. So we will start from the ranked proposals which are above threshold after the evaluation, and we'll perform the following steps. If present, at least one proposal will be added to the portfolio dealing with each of short, mid, and long-term storage, since each of these timeframes presents its own set of challenges in terms of the stability of the molecules used and the technologies required to manipulate them, and the opportunities in terms of possible applications. So what does this mean? It means that if, I mean, just to be extreme in my example, if the top 10 ranked proposals in terms of score all deal with long-term storage, we'll look further down and try to see and add to the portfolio at least one project which short and one project with long-term storage, just to satisfy these particular considerations. The second consideration is portfolio construction will encourage a degree of diversity in the underlying substrate, DNA, other synthetic polymers, living cells, etc., whilst acknowledging the current emphasis on synthetic DNA. So again, this is pretty clear. We are looking for diversity in terms of the substrate. Just to mention the whole process at the end, it's the remote evaluators under the guidance of the program manager who are going to look and decide exactly which are the best top ranked projects which should be added to the portfolio. So the third consideration is the committee will encourage proposals that demonstrate end-to-end integration and interoperability if appropriate to the category. So what this means is if we have two proposals with more or less the same scores, we'll prefer to add to the portfolio the one which demonstrates better this end-to-end integration and interoperability. And the fourth portfolio consideration is that within each category, the committee will seek, where possible, diversity in terms of potential applications. For example, within the long-term window, they may look for applications that require different levels of fidelity of the data storage. So again, this is, I believe, clear. We are looking for diversity in the application of the solutions proposed for this DNA storage. And I believe this completes the presentation on the call text in the work program, and then the challenge guide outlining the main details which you have to really study, understand, and follow when preparing your presentation. You have to understand well what is the overall goal and the specific objectives. You have to propose something which is within the scope, and you have to address also the expected outcomes and impacts. And then you should be aware of the way we are going to build the portfolio using the specific categories and portfolio considerations. So again, to remind you, if you have questions and you have not asked them yet, you can do it using Slido, going to the right place, or using the field to the right on your screen. So thank you.
Thank you very much, you, Roumen, for this very clear presentation. So we have some question already, and we address first the one that are really related to the challenges. So more on the content, and if time allows, then we will also address the question that are more on the eligibility and more general. So the first question is DNA computing also considered as a possible component of the portfolio?
The DNA computing, it is, I mean, again, when building the portfolio, let me emphasize, we start with the ranking based on the evaluation, and on top of that, we will superimpose these additional portfolio considerations after we have identified where the different applications fit into the two categories. Now, the DNA computing, it's my understanding that it's part of the possible applications. Now, in general, we're looking for storage, but computing. Let's put it this way: if the primary objective of the proposal is developing DNA computing and not following the DNA storage requirements, although the two are clearly related, then it may end up being out of scope. I mean, still, when we talk about the scope of the proposal, it's DNA-based storage. However, if you develop a proposal which discusses and advances the DNA storage, and you have the DNA computing on top of that, that's clearly it's going to be an advantage, and it will show a specific application how the DNA storage is going to be used. I believe this is the way it should be considered.
Okay, thank you, Roumen. So then we can move to the next question, which is in the categories storage substrate, should the applicants aim to both categories or only one? For example, aim as higher as possible in one category or balance?
Honestly, I don't understand what does it mean high or low for a category. I mean, looking here, the categories, I hope you see them. There's a storage duration and there's a substrate. And on storage duration, I cannot say it's better to have long term than to have short term or mid term. I mean, they're all important. We would like to have at least one from each one of them. But I cannot say which one is better, which one, let's put it this way, which one we will uh, lead to a higher probability that you're going to be selected. I wouldn't say one is better than the other. Same for the substrate. We're just trying to make sure that in the portfolio we have diversity in the substrates. However, if it just happens in the ranking from the remote evaluation in the top 6, 7, 8 proposals, we do have the diversity you're looking for. We'll just stick to the ranking from the remote evaluation, and I mean, we will have satisfied the portfolio considerations. So, I mean, just again, this is important. For each one of the categories, your proposal will be somewhere in this dimension, or maybe at several places, but it does not, there is no better or worse positioning within each one of the categories for the purposes of building a portfolio. For the building of the portfolio, we are looking at the whole set of proposals. So it's very difficult to answer for a single proposal what is a better value for one or for another category.
Okay, thank you, Rumen. So we move then to the next question, which is how can we know how many proposals are in one given category in order to choose a category not or less covered by other proposals?
This is exactly like the previous one. I believe, I mean, just correct me, but if you're submitting a proposal on DNA storage, it is going to be either short term or mid term or long term, or maybe a combination of these, or several of these are going to be addressed, but there is no way I think it can be outside this category. So that's, I mean, as I said, there is no better or worse value for your proposal for each one of the categories. It depends on the set of proposals we receive and how the portfolio we're trying to build is going to be created using the standard, the so-called the portfolio considerations, which I just showed to you.
And Rumen, if I may add,
Yeah.
you should just focus on writing excellent proposal because you will be considered for the portfolio building only if you're really top ranking. Okay, so we move to the next question, which is more, I would say, administrative or general. Do the legal entities that need to be in different EU countries, I guess, for consortia?
I would suggest you consult the definition in the work program exactly. I copy pasted here. Just a second. Let me put it back. Here it is. Uh, huh.
Yeah.
This is
So it's
something I should know, but please check the
so it's a page
definition.
147 of the work program. So consortia are defined by at least three legal entities established in different countries, member states. Yeah.
Okay,
So
so
proposal for multi, yeah.
yeah, Isabella, this is the standard definition for three legal entities, but we have for the challenges specific requirements which allow
Yeah.
also consortia with only two legal entities, and
Yeah.
these are defined in the beginning of the in the work program when we discussed the challenges. In the beginning, we define what we mean by consortia there. I mean, this is a very important question. We'll check and we'll come back to all of you with the explanation for this, just to make sure that we will give you the right answer. I mean, we don't want to make a mistake on this one. If
Okay.
there are
Yeah.
two legal entities, if they're from different countries, in my opinion, they should be, but let me check.
Thank you.
Yeah.
The other question is a single entity from EU member state plus a Swiss or UK or Canada partner considered a consortium or not?
It is a consortium. It's a consortium with two legal entities, and it's eligible. Now, one should make clear distinction between eligibility to participate in consortium and being eligible to receive directly funding. I believe this was discussed in the morning, in which cases a partner in a consortium from not from associated countries or from a EU member state, when such a partner is eligible or when such a partner can receive funding, it's something which is going to be assessed during the evaluation if they satisfy certain criteria, and they may receive funding. But in general, not all partners in consortia, those coming from outside EU and not from associated country, not all partners are eligible for funding.
Thank you. So the last question that we have at the moment is having a consortium partner focus on innovation management and exploitation of the solution generally considered a benefit?
Thank you for this question. Generally, it is considered a benefit. However, when we evaluate proposals and when we give scores, we always try to stick 100% to what is explained in the work program as criteria for evaluation, and in this particular case also the portfolio considerations. And since this particular feature is not an explicit criterion for evaluation, it should not impact the final score or the decision on joining or not joining a portfolio. So it's good to have, but it's not part of the things we evaluate.
Okay, thank you. So there are no more questions at the moment, but we still have some time. So don't hesitate to write down your question in Slido.
Oh, by the way, you'll receive the presentation. You have my email at the end of the presentation. Don't hesitate to send questions. We will answer them, and actually we will send the answer to everybody. So I believe it's going to be useful at this stage that everybody who participates in this presentation receives the answers to all the questions being asked.
Thank you. So we have in the meantime one more question, and
Yep.
it is, what do you mean by interoperability?
you got me here. Okay, so here is, I don't know if I managed to address the questions until now, not being an expert on the field. But for this one, I have to come back to you independently to explain what it is after consulting with experts on the field. So I'm sorry. I will come additional with explanation about interoperability.
Okay, thank you very much, Roumen. So I'm not sure we have more question at that time. So we can wait a couple of minutes if any one of you would like to put a new question in Slido. But as Ruma said, we are always open to answer any question you might have, when writing your application. So you can contact us via email.
However, let me also mention something else. When asking your questions, we'll be able to answer general questions, and we will try to share the answers with all the participants here in this presentation. On the other hand, we will not be able to discuss with you specific questions about your proposal. For example, if you ask, is this a good idea? Is this satisfying your requirements, and so on and so forth? These are the kind of questions which we avoid answering simply because it will put the others who have not asked the question, have not received an answer in a non-even situation. So we are trying to keep the field as leveled as possible. So as I said, we are not going to answer specific questions about your specific ideas and specific approaches. So we'll address only general questions.
Yeah. So I guess there is one more question. So would a work package dedicated to collaboration with other projects on the portfolio be seen favorable or void?
Okay. Similar to the previous question, this is not a specific requirement, and this is not something which is going to be evaluated and to improve your score. In case your proposal is ranked high enough after the evaluation on the criteria for evaluation, and if it's selected for the portfolio on the basis of the portfolio consideration, so it's added, it's selected for funding, then in the process of grant agreement preparation, what we are doing is we are proposing all the selected for funding proposals to add such a work package, and we suggest specific details for this work package, but this is for after you have been selected for funding and you're in the grant preparation. So at this stage, when you prepare a proposal, it's I would say it's going to be just waste of space, which is precious for you to express your ideas.
Thank you, Roumen. So we'll wait a couple of minutes. Maybe a general suggestion to applicants is that you should have really a look at evaluation criteria that will be used, because we will be really sticking to that. Yes. So someone is asking you your email.
Oh,
Maybe
sorry.
you can share your
Let me put
slide.
it back. I'll put it on screen now.
Yeah.
Just a second. But also, as I mentioned, the the presentations are going to be shared with you, so you'll be able to find it also afterwards.
All right, so I think then we have now reached the end of this breakout session. So we thank you all for attending.
Thank you.
And we wish you good luck for the preparation of
Yes,
your
absolutely.
proposal.
Good luck. Thank you.
Have a good day, all of you. Bye.